we get given a quadratic graph, ax squared plus bx plus c, its minimum point and one of its roots. And what we need to do is go back and find the actual graph itself, the values of a, b and c. The way we should start this question off is with the 2 points that we're given. So a minimum at 5 minus 3 and one of the roots at 4, 0. So I'm going to sketch these on my graph to start getting an idea of how this thing looks. So 5 minus 3, I'm going to sketch down here somewhere, 5 minus 3. And 4, 0, well, it's not quite as far along the x-axis as our minimum point, so I'm going to put it maybe here, 4, 0. It's just a sketch of this graph. Well, we're a bit stuck now then, aren't we? Because we've got minimum point and one root. Well, we'd like to know where the other root is for our quadratic. And actually we can get there from a bit of thinking about the properties of parabolas, aka the nice curvy shapes that quadratic graphs are. And the way that we get there is by realising the minimum point has to be exactly halfway between two roots. Parabolas are always symmetrical. So if we have one root at 4, 0, the minimum's at 5, 3, our second root has to be at 6, 0. Because 5 is exactly halfway between our 4 and our 6. Okay, that's really helpful then. Now we've got two roots of our quadratic. It's tempting to think, well, if it goes through these two, it must just be x minus 4, x minus 6, because that fits those two roots. But this isn't our graph, and we're about to see why. So if we expand this out, we would get x squared subtract 10x as 24. And when we're thinking about the minimum point, we should be thinking about completing the square to understand where the minimum point of this graph will be. So let's do that. We need to halve our minus 10x to get minus 5, square it. We're going to take away 25 because that's 5 in the brackets and add 24. So this would leave us with the completed square form of x minus 5 squared minus 1. And that tells us that the minimum point, is at 5 minus 1 for this curve. And that just doesn't really work with our graph because our minimum point is at 5 minus 3. It almost works. What we need to think about is stretching this graph out. So x minus 4, x minus 6 almost works, but needs to be stretched out because the minimum point of this thing will just be at 5 minus 1. So if we wanted to sketch it, it's going to look something like this as a quadratic. We need to stretch our graph out on the y-axis, and the way that we do that is by introducing a coefficient in front. We need to think about the factor of this stretch. And to do that, stretching from minus 1 to minus 3, we need to stretch by a factor of 3 times, don't we? We need to stretch it out 3 times. So our graph will now look, I'll draw this nice stretched out version, 3 times as steep as x minus 4, x minus 6. So if we add in this 3, well, when we expand that out, it's actually going to give us 3x squared minus 30x plus 72. Right, we've times the 1 by 3, the minus 10 by 3 to get minus 30, and the 24 by 3 to get 72. So this would be the answer that we're looking for A, B, and C.